Good morning. Thank you very much for this opportunity. This morning I read a short article by Robert Bryce, or actually an excerpt from his article. He tried to evaluate the access to electricity across the world by referring to his kitchen fridge. Kitchen fridge uses roughly 1,000 kilowatt hours per annum, and 45% of the world's population has less than that available. Another 35% of the world's citizens have between 1,000 and 4,000 kilowatt hours per annum available, and only about 20% have more than 4,000. So it seems as though those numbers could actually be applicable to the South African case as well. So very briefly, let me start by addressing the main points. We need clean energy urgently. Something about the dual energy challenge. Great opportunities. The question is, if not, why not? And then some conclusions. We've just seen from the previous speaker's presentation that South Africa seemingly has and has had for a long time the ability to analyze any particular crisis problem into quite extensive details. And we also have the ability seemingly to plan ahead. So what's going on in our current situation? I will take a slightly broader view by looking also at what happened on our continent. And I also thank my co-panelists for the participation in a recent report to the NSTF. So we have a growing population and we have a growing energy need. That is kind of general knowledge. This nicely depicts where we stand. This is worldwide. And then if you look at the South African situation or the African situation, as we've just listened and just heard, that we have a lot of energy losses per annum, and it is seemingly growing. So we are currently on par with the developing countries average, around 8–9%, but we're seemingly heading towards the African average, which is around 16–17%. Here you can see also the average energy losses per annum. At least our share of annual outages seems okay so far, but it is probably headed for the wrong way. If you look at the current use of renewable energy across the world, it is clear that Africa, and notably South Africa, has a lot of catching up to do. I also think our future planning is insufficient. Currently in North Africa, it's primarily fossil fuels, gas and oil. South Africa is, as you've seen, relying heavily on coal. The rest of Africa seems to be using some bioenergy, but that is mostly firewood for cooking and for heating purposes. So if you look at the rest of the world in terms of additional renewable energy planning, it also seems that Africa is lagging behind. And that is something that we need to address. So what is this dual energy challenge? Firstly, we have an increased number of people without access to electricity. We should at the same time attempt to decrease CO2 emissions. We obviously need an increased foreign investment. So we think that Africa, notably South Africa, can really leapfrog to a green energy solution. On the right-hand side in this picture, you can see that while the rest of the world is seemingly reducing the number of people without access to electricity, in the sub-Saharan African context, it is seemingly increasing. So the GDP per capita and the per capita consumption emissions are linked. We know that energy is a major driver, a primary driver for development. And unfortunately, the situation is that one wants to move to the right on this curve. You want to increase in any country, you would want to increase the GDP per capita, but at the same time, the environmental imperatives are such that we need to simultaneously reduce the CO2 emissions, greenhouse gas, and other environmental burden that we carry. So on the left-hand side, there is this, let's say, on average, upward vector to the right, and up to the right is fine, but up is not good. On the right-hand side, you can see the improvements that many of the developed countries or even developing countries have been able to achieve by aiming towards a lower CO2 per capita release, at the same time increasing the GDP per capita. So this dual energy really is about energy deficit and the climate imperatives. South Africa is about here, sort of on the verge of energy poverty, but potentially at a point where we would further increase our CO2 footprint. So, like the CSIR, there are other people out there who think there's a more ambitious and a better energy future possible for South Africa by embracing renewables more ambitiously. So the African Energy Outlook report, which is closely linked to the World Energy Outlook report, it's a very influential report. It looks at lots of data over a very, very long period in time, lots of analyses, many experts knowing these various fields, and they have proposed the so-called Africa case, whereas the curve on the left, or the plot on the left, is what we could expect if we remain on the so-called stated policies. So Africa has also been blessed with a lot of gas findings lately, and that would probably also feature in future energy planning, notably as a backup when wind and solar cannot supply or might be intermittent. And then obviously other storage technologies, we'll touch on that very briefly. It was interesting for me to look at this plot. Even though our uptake of renewable energy and our general access to energy in Africa, sub-Saharan Africa, is rather low, there's a remarkable uptake of electricity from renewables. Presumably, these are all small-scale solar panels to panel the odd cellular phone, or maybe some small household device or so, perhaps even here and there, some small wind installation and the like. So there's a real opportunity for sub-Saharan Africa, including our country, to embrace these technologies as low-hanging fruits and to accelerate the uptake. The question here is, can we really fix a system as large as our electricity supply system overnight? We cannot do that by erecting plants overnight. Presumably, we have to fix what we have, but we know there's a lot of neglect in terms of long-term maintenance. It's not going to happen. We see that. We saw that from the previous presentation. Secondly, we can rely on imported gas. And a few power ships in the harbor might do it for a short while. It would be absolutely unacceptable if they stay longer than a few weeks or months, let alone 20 years, as is seemingly planned in some corners. And then lastly, we could dramatically deregulate and deploy renewable energy. So the great opportunities for a remarkable energy transition includes also the labor market. This slide just depicts the potential restructuring in the energy job market should one, in a rather evolutionary manner, transition into a dispensation where wind and solar, in general VRE, are more widespread. And then the next slide to me was quite a revelation. That if you look at the job years per gigawatt hour produced or sustained, this is really remarkable, especially in sub-Saharan Africa, especially in South Africa. And I do not think that the unions always bring this picture to the negotiation table. Because yes, there are some entrenched interests, we understand that. But the potential for job creation in renewable energy is largely overlooked. This could have huge economic development inputs and potential. I need not dwell on these. We all know that South Africa is blessed with solar energy, even wind. If you look at the scale on the left-hand side here, north and south in Africa seems to be wind ready, and we've seen the deployments in South Africa. I need not say too much about biomass. Besides that, there is a lot of potential biomass stocks that we're not using in Africa. If you compare, for example, the situation in South America, you can see that there's a lot. We know about those success stories. Then we all understand that with the development of storage technologies, the need for base load would probably reduce dramatically. And the progress shown in these various storage technologies are depicted here in terms of the capacity for supply as well as the so-called discharge time duration. Just need to mention that I think in the case of batteries, for example, we've already seen recently, I know about a gigawatt hour battery in China. Last week I read something about a 1.3 gigawatt hour battery commission. So there's great progress here. The promise of hydrogen needs to be looked at, and my colleague spoke about this in the previous lecture. I'm not going to dwell too much into this, but that, as well as synthetic natural gas, where CO2 sequestration and hydrogen could be used to actually store energy in the form of synthetic natural gas, is also a huge possibility for the future, as the same goes for ammonia and so on. So I'm just sort of briefly touching on hydrogen. There are various ways of producing hydrogen, and with various footprints. There would be a transition from black, brown, etc. These colors really just refer to the intensity of the greenhouse gas footprint, whereas green hydrogen would be the cleanest. And then the usage, the potential and the possible usage of hydrogen is immense, not just as a fuel, as we've already explained, but also as a chemical in so many industries where currently a lot of fossil fuel-based energy is used to produce those chemicals. We see the pathways, and I think the DSI needs a commendation for the farsightedness in this regard. We just would like to see more of this happening and faster. So what is holding us back? It is quite obvious that we have abundant renewable energy. We've touched on the jobs. Now, as far as safety and the environment is concerned, it seems to be, in typical American jargon, a no-brainer. Wind solar is even more safe than nuclear. And although I have a nuclear background, some of my nuclear friends think I'm a renewable energy proponent and vice versa. This very same Robert Bruce said this morning, if you are anti-nuclear and pro-green, you must be pro-blackout. So we saw some pictures on baseload availability and the international pressure on reducing coal, which we seemingly don't always take to heart. So in terms of safety and environment, this is what we're looking at. Then in terms of the levelized cost of electricity, all of this is influenced typically by the short rollout times of VRE, the fact that it can be decentralized and flexible, its scalability, and so on. Looking at, for example, the LCOE and across a whole range of energy sources, the only real competitor to renewable, notably in our context, solar and wind, would be long-term nuclear, such as Kuiper, where the plant life extension would extend the plant from 40 years to 60 years of life. Now, that would be remarkable. At the same time, storage technologies are becoming less expensive. You can see the dramatic drop in price in, for example, lithium-ion batteries on the left-hand side. On the right-hand side, a remarkable drop in price over just 10 years of solar, onshore wind, whereas more conventional technologies, coal, has been basically constant, gas seemingly slightly less expensive, nuclear more expensive. So it seems as though there shouldn't be any doubt there should be no question. And the very interesting fact to note is the fact that the price per megawatt hour of electricity is also, in the case of renewables, dropped, whereas in the case of the other technologies, there's not been that advantage of a learning curve. So other advantages with variable renewable energy includes the possibility of really wide public participation. Empowerment is something that could really be achieved, but in the correct manner, not the manner some people seem to interpret that. Something that would empower whole communities. Relatively little new development is necessary to fully embrace the potential of renewable energy. And the CapEx exposure is also much less risky than in these 30, 40, 50-year programs. And that is a topic on its own. Right, so what's holding us back? If you look at our integrated resource plan, it seems as though the rest of the world knows something that we seemingly do not know. We still have way too much coal. We're still playing with the idea of new coal in the Waterberg, I believe. We have a much less ambitious renewable energy trajectory, seemingly, than the African Energy Outlook team have suggested Africa to look at. Although there is attention to storage, it's probably insufficient in terms of what we can really achieve there. There is seemingly still an over-regulation of renewable energy suppliers at all scales. The recent announcement to allow the 100 megawatt renewable energy ceiling is much welcomed, but I think we can do far better than that. And there's also seemingly a disjunct with the integrated energy plan. So the IRP is what we have now, but I think it has a few problems. We can really improve on that. So I'm going to skip this slide. It basically speaks to the previous in terms of the stated policies and the Africa case. But perhaps just on the right-hand side in the Africa case, this would be the kind of trajectory that one should embrace. And it was heartening to see that the CSIR, the second last slide from Jared, I think showed very much the same kind of trajectory. And this is obviously better than what we're currently looking at. So just a few salient points. We have an absolutely compelling renewable energy business case. Prioritization of renewable energy should be expected within the highest offices of government. Africa could be the first continent where renewables and gas play a prominent role in supporting a shift away from fossil fuels and bioenergy and underpinning economic and industrial growth. The most, perhaps, if not the only, viable short-term solution to the current energy challenge in South Africa is unhindered deregulation of VRE and large-scale public participation in the rollout. Jansi, your question a while ago, this is my energy profile. I have a small solar setup, 5 kilowatts peak, and a 10 kilowatt hour battery pack. It is unheard of that a small scale supplier like myself can make my own electricity cheaper than I can buy it. And this is the kind of profile, Jared, just to refer back to the profile that you showed, there are millions of South Africans who could shift their power consumption into the solar domain and thereby circumvent unnecessarily big batteries so as to obtain a relatively small, or let's say purchase a relatively small amount from the grid. So the next point is, again, a sense of urgency. Accelerated deregulation to enhance broad participation. I do not think the problem is technological. There are so many technologies out there Presumably, the situation is exacerbated by political considerations. And unfortunately, the energy politics in our country has been not entirely savory. Many of the public debates and accusations have been flung around. You be the judge as to whether any of this is correct or not. We have a very proud, and we had a very proud energy supply system in South Africa. The problems we currently have not emerged overnight. It's not something that broke overnight. It's a question of long-term issues in our household that we need to get a grip on. Otherwise, we will see where the current situation endure for quite a long time. I do think that with a dramatic deregulation, even subsidy for households, as we did with the efficiency program, would see an overnight shift of load peak profiles into an area which would probably clip our peaks tremendously, and also would see a large uptake by the public. So thank you very much.